他写的是你，
这样容易吗？
很像。
我这应该是画圈圈的，用作固定。我们去一下。我们在瑞贝。
我刚去没看到。
对。在。
有。
没人在。我看没有人。是他们来找我。
8个小时。
放地上。有没有好的？你讲，哎，叫我试一看。你有个妹妹来，正好不要来。
给他读书吧。
跟我们来。
好的。
要看 video 吗？要看 recording 吗？
这次我不懂啊，不知道。
我讲话还听得到。
听到哈。
Hey, good afternoon all. So how are you guys after a long weekend, long holiday? Friday, Saturday, Sunday. Not good. Huh?
Still very tired.
Very tired because of midterm assignment.
Yes.
Yes.
And
Nicholas.
Nico.
Yeah.
She helps me feel not as tired.
Wow.
How? Huh?
Because she made you tired.
No. If she's not here, I die already.
Okay. Alright. So hi, morning, afternoon. Before we start, there's one announcement regarding to your midterm. So remember last time I provide two options to you guys. So the first one will be the 30th of August. Okay, the second choice will be the 1st of September, right? Both 6:30 to 8 p.m. But after I discussed with other others programs, some of them they have a replacement class on the 1st of September. So I have to choose the 30th of August, 6:30 to 8 p.m. So whenever you got a replacement class, whenever, please let me know early. So I have to make another arrangement. Otherwise, then I will stick back to the 30th of August, only chapter 1 to chapter 6. So very simple. No machine learning. In the past experience, all the while I include machine learning and unsupervised machine learning, but this semester I will just include until the NLP. Okay, so is that clear? Okay, so if no any objections, yes. You have class until 7. Okay, 7. You have class until 8.
Yeah. Before delay.
Huh?
No need.
No need midterm test.
No need.
See you next semester.
Yes.做什么？
哦，对，没想你听到认真。
떡볶이를
29?
일레 cannot.
Check, can you help me
We until 8.
until 8?
Yeah.
Simulation
Simulation.
or class? Class.
Class.
So you have only Wednesday. Then we have to make.
Monday is okay.
I cannot. We already get asked from management. They don't allow.
Saturday.
Huh?
Then don't ask lah.
Cannot.
Just close eye. I think.
Once student report, then I control. The next semester you won't see me again.
Ah.
Huh?
Other school I pay.
How about 6th of September?
Can.
Every Wednesday until 8.
Thursday is
Tuesday cannot. Wednesday cannot.
Thursday. Can ah.
Can ah? Can you help me to check 7?
5.
7 is Thursday, yeah? 7 is Thursday.
我签到的电话嘛，跟上面差不多。我们有的是 10我们有的是
This is week 10 already.
10
We must have a midterm test.
Can.
Okay, so tentatively on 7th of September lah.
So maybe you spread you split to 2 group then paper you set different
I set 2 sets of paper.
then easy
Difficult for me.
easy for us
See, if I set two sets of questions, maybe one will be more difficult one. One will be maybe. Then student will complain. It's not equal.
then 我们
So tentatively since this one cannot, this one cannot, this one cannot, then only this one. Week 11, week 10, week 10. Okay, so I think today we have quite a number of things to cover, which is the supervised machine learning. So as usual, before we start the supervised machine learning course or class, is just a recap for last week, the chapter 6. So chapter 6 we learned NLP, right? The process, the natural language. So there are two purposes of NLP. The first one is to understand, to make the machine to understand what humans want. It's called NLU. And second one is called NL.
放随便拍这个责任是交给你
NLG, okay? Natural Language Generations.
我的 channel 可以关掉
So under the NLP, we also seen several number of applications like the text summarization tool. Okay, we have search engines, paraphrase tools, and chatbot. A lot of applications, and we have seen also some of the important libraries. For example, the text block, NLTK, used to deal with the natural language. And also we have seen some of the challenges that you may face during this NLP, especially the knowledge, right? It depends heavily on the domain of discourse, this is in the slide here. And also we have seen the ambiguities, right? The unknown, something that's unknown, for example, semantic ambiguity and syntactic ambiguity. And also we have several limitations or the challenges. For example, especially in Malaysia, we have too many languages, and also we like to put a lot of so-called different language in one text, so it makes the machines hard to understand. And also we have a lot of typo errors, emoji, some abbreviations. Okay, so again that will make the machine hard to understand, hard to interpret what user trying to convey. And also we have seen some typical symbolic analysis in the NLP. Okay, for example, we have a morphology analysis. Okay, morphology analysis, where we break the words into the morphemes. Okay, which is the smallest units of word that carrying the meanings. And then we have seen some analysis deal with sound, for example, the phonology. Okay, and then we have a prosody. We have this semantic analysis. We have a syntactic analysis, and we have a so-called pragmatic analysis and word knowledge analysis. Okay, or called ontology. So all this is in the slide, in the slides. So just a summary for the last chapters. So we have done the chapters 5 and 6, which deal with the natural language. So chapter 5, we have knowledge representations. So before we build any applications, we need to provide the knowledge to the machine first. Then only we proceed to the NLP. Alright, so let's move on to this new topic called machine learning. So I have modified a little bit on the slides. So you may see the slide that I've shown, my project here is slightly different than the one in the Google Drive. So it's not much difference in terms of the content. Just I add more example and polish some of the content. Okay, so today we are going to see what the type of the machine learning, what are the important elements in supervised machine learning, what is the proper process flows of supervised machine learning, what is overfitting, type of supervised machine learning, especially in the regression and also the classification. And lastly, how do we assess the performance of the classification? Okay, so how machine learning is actually, you have to understand first. Machine learning is what? Machine learning is a branch to aim. The purpose is to train or to make the machine to learn based on the data, find the underlying patterns. So how the machine learn is actually, you have to understand how human learn first. How human learn reflects how machine learns. We use the exactly process on how human learn into this machine. Okay, so machine learn through what? Observations. Okay, through the trial and errors, through the past experience and mistake. So through the errors, the observations, the experience, mistake, then we review ourselves and we can make our better decisions. For example, in the first case, you have a kid that fall down, right? So next time he knows that he's not going to run, right? He knows that he runs, then he fall down. So then the next time he learns from the mistake, he's not going to run anymore. In the second case, let's say now you as a kid, you see your brothers kick the balls inside the house and then break the windows. Then he gets scolded by the fathers, the parents. Then you know that you're not going to repeat the same mistake in as what your brother did, okay, to avoid the same so-called the mistake. Okay, so this is the definitions of machine learning. So Kelvin is one of the famous computer scientists. He says that what is machine learning? Machine learning is a set of methods that automatically detect the patterns in a set of data. So from the set of data, he tries to uncover the patterns. Right? You have a lot of data here. You try to find what is the relationship, the patterns between the data itself, and then from the pattern itself, we can make the decision, a new decision. Let's say we have some unseen data. Okay, some terminologies that you have to understand first before we move on. Probably you have heard about what machine learning, deep learning, neural networks, AI. So what are the differences between all these things? So artificial is like so-called big branch. Okay, so artificial refer to any applications that mimic human behavior. This one we have learned in the chapter 1, I believe. Right, what is AI? So AI is any applications that having human behavior, mimic human behavior. So under the AIs, we have a subset called machine learning. So machine learning is ability to learn. Right, the machine is able to learn from the past historical data, discover the patterns, and find so that it can make the decision. Right, able to learn and make decision without being explicitly programmed. So what does it mean? It means that we no longer need so-called rule-based, right? In the past AI, so we use a lot of if-else rules. So if you see this one, then we do this one. Okay, if we see this one, then we do this one, and so on and so forth. So this is the AI, right? It's able to perform like a humans. But what is the machine learning? We no need if-else rules anymore, but instead we pump a lot of data into the machine learning models. So the machine learning model will try to find the pattern between a lot of data here. So we have a lot of data. Okay, find the pattern between this kind of data so that whenever we have something new data, it is able to predict or so-called the make decision. Okay, so this is machine learning. No more if-else rules. I believe that you have gone through the practical in the machine learning. You try to go through again the machine learning codes. There's no more if-else rules in the code. Okay, where I show you. So this is the code, right, in the machine learning. So we will go through like for the first case. For example, in this case, so we have a data set here. We straight away pump this data set into the machine learning models, which is so-called linear regression. You see that we don't have any if-else rules to train the models. If you see this value, then give me the output. If you see this input, you give me that output, no more. So we just throw all the data into these machine learning models, let the machine learning models to find the patterns between the X or between the Y, and come up with the models so that it can predict something new. Okay? And then under this machine learning here, we have a neural networks. So neural network is actually a backbone to build a complete deep learning models. So it is kind of the machine learning, but it's to mimic human brains through a set of algorithms. So we won't go further about these neural networks. I will just cover a little bit in the neural network in the chapter 9. Okay. And then under the neural network, we have a deep learning. So what is deep learning? It's actually referred to how many neurons. Okay. If you have a more than two hidden layer of neurons, that is so-called deep learning. Okay. So what is the machine learning and the deep learning? The difference between the machine learning and deep learning is that machine learning, we still need to pump the features. We need to extract the features and to teach the machine, okay, you have these features and then this is the output. But in the deep learning, we no need to tell the machines which one is our features. We just throw everything inside. The deep learning will find which one is the suitable features to train, to learn. Okay, so it's getting smarter and smarter. So this is our focus today, machine learning. There are several types of machine learning. Okay, there are several types of machine learning, so-called supervised, unsupervised, semi and reinforcement. However, in our syllabus, we will just cover two types of machine learning. The first one is called supervised, and second one is unsupervised. Meanwhile, for semi-supervised and reinforcement learnings, this one we need your own effort to study. If you are interested, then you can study what is semi, what is reinforcement. But if you can understand what is supervised and unsupervised, then it shouldn't be a problem for you to understand semi-supervised. It's just a bit in between of supervised and unsupervised. Okay. So today we will cover supervised machine learning. We will look into some of the very common supervised machine learning algorithms. In the practical, you just call the function. You just call naive bias, for example, and train X and Y. But you don't know what is the concept behind the naive bias, or what is the concept behind the decision tree. So if you don't understand what is the concept behind each of these algorithms, then you may come to the problem where you will just try and errors, right? You have a data, you try support vector machine, you try what is the accuracy. Then if low, then you try decision tree. You never know what is the concept behind each of these algorithms. If you can understand, then you know which parameter that you should fine tune. Okay, whether this decision tree is suitable to predict your own data. If not suitable, then you should change the algorithm. If you don't understand, you just try and error. You don't know what's going on behind the algorithm. So it's good for you to understand, okay, how this algorithm works for each of these. So I'm not going to cover all the algorithms, but I will just choose the 4 which is very commonly used in academics wise, or in terms of the so-called the company. They like to use decision tree. So I'll explain in more details. So next week, then only we'll go into the unsupervised learning. So what is the differences between the supervised and unsupervised? Supervised learning is mainly used to predict, okay? Supervised machine learning mainly we used to classify or predict something new. Okay, we have some unseen data here, unseen X, okay? So we go into this supervised machine learning. So this supervised machine learning need to predict whether it belong to class A or belong to class B. Okay, so this class A and class B are actually predefined. For example, A is a female, B is a male, or A is true, B is false. A is a so-called it's a car, B is a motor car. So you need to predict something new and classify this into a predefined classes. So what is unsupervised machine learning? Unsupervised machine learning is where we use to cluster the data. It's called clustering. Okay, so what is clustering means that we have a lot of data. Okay, we have a lot of data here. So this unsupervised machine learning will just help us to find which data are quite similar to each other. So these are very close to each other, so we put them as one group. So this is very close, we put them as one group. This very similar, we put them as one group. There's no predefined classes. That's why in supervised machine learning. In supervised machine learning, yes, we have a very clear defined classes, whether it's a female or male, whether it's true or false. But in unsupervised machine learning, no. We don't know what is this, we don't know what is this, and we don't know what is this. The unsupervised machine learning, we just try to use the algorithm to find which data are very similar to each other and then group them together. Let's say now I have a new data come in, something like X. So this unsupervised machine learning will find again the similarity between this to this group, this and this group, this and this group. Oh, this is actually quite close to this one. So we can say that this X should belong to a group, for example, A. So this ABC is not class, but it's a name for the class. There's no meaning for ABC. For this one, yes, there's a meaning for this of a class. For example, female and male. So this is the differences between supervised and unsupervised. Next week, I will cover more details about what is unsupervised, but today you just need to understand what is supervised machine learning. It's mainly for classifications or prediction. Okay, classification or prediction. Is that clear? Okay, so let's move on to the part 1 supervised machine learning. So as I mentioned, before we understand or we move on to the algorithm for each of the supervised machine learning, we have to know first how human actually learn something. Okay, when you look at this picture, we have a two group of people here. Okay, the first group of people, we have a 6 students, let's say. Okay, look very handsome, very pretty here. We have a 6 students. Okay, so based on these 6 students, we try to understand their CGPA. We find their CGPA. Oh, and then we find out that this is 7, 3.9, 3.8, 3.9, maybe 4.0. Okay, so we put them inside a group called excellent grade. They are having an excellent grade, near to 4.0. So this is one class of people. Okay? Look like Brandon. This one.
Hair already come out.
Hair already come up, so no more. This one is before Brandon. Okay.
Hair come out at the bottom.
Okay. So we have a second group of people here. Yeah, we have a second group. This is the second group of people. 1, 2, 3, 4, 5, 6. We have a 6 student also. So we try to identify their CGPA. Maybe their CGPA is average, 3.1, 3.2, 3.3, and 2.2. We put them inside one group and give them a name called average grade. Okay? Can. So identify. So understand? So we have a 6 students. So these 6 students we put inside the excellent grade. And then the second group of people, we identify the CGPA, we put them inside the second group. So our objective is we like to predict if, let's say, now you have an intake, a new students, look like this, a new face. Can you predict? Okay, can you predict based on what you have learned? Why Chinese? Look like who? Look like you.
有理想型啊。
Oh, your idol.
Yeah, their father.
Your father. Okay, let's say now you have a new student. Can you predict after 4 years whether this new student will score excellent grade or will score average grade?
4.0, like Brendan.
5.0, maximum 4.0. Based on your understandings or based on your interpretations, you have 2 groups of people. First is excellent, second is average. So you have a new phase here. We would like to predict after 4 years, these students will belong to excellent grade, which is score near to 0.4.0, or this student will score like near to 3.2 or 3.3. A disclaimer, I just put an example. Don't get offensive. Let's say you look like someone else inside the picture here. No offense, just examples. Can you predict? Yes. The hair. You belong to group A or group B? B. So it means that after 4 years, we predict this student, assume that this is a student, he will belong to so-called the average grade. Why? My question is why? You have these conclusions. Look like? Look like similar. Similar in terms of?
Appearance features.
Okay, very good. So Brandon says because these students having quite similar appearance features as the group B. Yes, so this is exactly how human learns. So firstly, as a human, we need to identify what the appearance features. For example, the hair length, the hairstyle, the hair color, whether it's wearing the spec, the head size, gender, and so forth, right? So after that, based on the excellent grades, you try to identify what is their characteristic. For example, in the first group of people, they're having a short hair for a male, they're having a neat hair, they are not wearing a glass, they're having a mustache, their head size is rectangles, gender male or female, right? Then we have a second group of people. So this second group of people, you try to identify what are their characteristics. So they are having a long hair, their hairstyle is a bit fashioned, wearing a spec, most of them wearing a spec. Okay, the head size is rectangles and round. So gender is male. So based on this one, so before we go beyond this, so all this here, so this hair length, hairstyle, wearing spec or not, so this we call it as features. Okay, and then the excellent grade, average grades, we call it as label. So these two are very important informations in supervised machine learning. Okay, to build a supervised machine learning, you need 2 informations. The first one is called features, and second one is called labels. I think this one I already explained over and over again during the practical class. In supervised machine learning, we need 2 elements, we need 2 informations. The first one is called features, and second one is called labels. So we need to pump these 2 informations to the machine, let the machine to learn. If you have these features, then okay, what will be the label here? So you have these features, what is the label? If you have this feature, this is the label. So this is how machine learn, and exactly how human learn also. We based on this characteristic, or then we know the answer. Okay, and then after that, you try to identify. Okay, this student, this new student hit Okay, most of the characteristic in the second group. Okay, we hit 1, 2, 3, 4, 5. Meanwhile, for the first group, you only hit 2 characteristics. Then we can actually predict that these students will eventually get only average grade. Okay, so this is how human learns, and exactly we will use the same process flow and pump into the machine learning, supervised machine learning. Okay, so yeah, same. In this case, let's say we want a machine to identify the fruits. What are the fruits for these 3 picture here? So first, we need to pump in the features. We have to tell the machines that, okay, if the color is red, the size is big, and then this is apple. Okay, if this is a orange color here, the size is big, then it is orange. So if let's say this is a red, okay, the size is small, then this is a grape, and so on and so forth. We have to pump the 2 informations, features and label, for the machine to learn. So the machine will try to map, okay, if I have an X, so this is the Y. If I have this X, so this is the Y. So it will try to find the relationship between X and Y here. Okay, clear? So in general, so what is classification? That's why I call it as a classification. We have a different multiple classes here. So we will find what is the, let's say we have an unseen data here. So this supervised machine learning will try to classify whether this unseen data should belong to class A or maybe class B. It's called classification or predictions. So bear in mind, computer doesn't have any experience like human does, right? We learn from the mistake, we learn from the try and error here. Computer does not have that experience, so we have to give them the experience. So what is the experience? Data set. We have to pump the data set into the machine. So this data set is act like the experience for the computer. Okay? Alright, so why it's called supervised machine learning is because we provide the labels here. So this label here is actually like the answer, right? You cannot just provide the features. You will provide the features, then you basically ask the machine to learn what is the X. Okay, you have this characteristic, you have this characteristic. So what? Then after that, we have to provide the label. That's called supervised. We are here to supervise the machines whether you are learning the correct labels or not. If I have this, see this label, this characteristic, so I give you the answer. So if you see this characteristic, or this is a male, or you have this characteristic, this is a female, and so on and so forth. It's called supervised. Okay, we have to be there to supervise the machine, provide the label to the machine. Okay, so this is the equations that you probably will see. We have a 2 so-called parameters here, X and Y. Okay, X stands for the features, Y stands for the label. Okay, for example, in this case, we have a data set here. It's about loan applications. So we have 4 features. So in this table, we have to identify which one is the features and which one is the label. So let's say now we have age, whether has a job or not, on house or not, and then what is the credit rating. So these 4 we will treat them as the features. Then we will put them, let's say in the first user having this data. So this person's not approved the loan application. So let's say we have this second data is a young, not having a job, right? Not having a house, a good credit rating, is a credit card also get rejected, so and so and so forth. So how to represent this data in so-called equation here? So this is how we represent. Inside our data set, we have 5 informations. A1, 2, 3, 4 stand for the features, and then the Y is stand for the label. Okay. So can you look at this picture here? So Google is using the machine learning to predict the likelihood of patient death. So let's say you would like to predict whether what is the likelihood, what is the probability that this patient will die. So what type of features that you have to extract first? What type of suitable features? What type of suitable features that you need to fit into the machine learning model?
Patient gender,
Okay, patient genders, you need the gender information.
age,
Okay, age, very good.
symptoms,
Symptom, very good, symptoms. Okay, what else? Age, symptom, maybe occupations. Okay, occupations is whether it's a high risk or low risk job, and so on and so forth. So you basically can identify what is the gender, age, the previous diagnosis, present size, and lab result. Very good. So whether patient ID is important or not? Do you think patient ID is one of the important features to train the models? No, okay, good. So the patient ID doesn't bring any information, right? We cannot say that, oh, you have a patient ID 1001, or then the tendency that you die is very high. So that is not true. So the patient ID is not a good feature. So whenever you want to build a machine learning, supervised machine learning, you have to identify first which features are very suitable, which suitables are very important. Then only we use it to train a model. You cannot just simply get a data set, you throw everything into the machine learning. Machine learning will just learn everything. We just try to map everything X and Y together. So we first, we as a so-called the programmer, we have to filter first. It's called pre-processing. Okay? So this is the overall process flow for supervised machine learning. So we need a data set. Okay? So from the data set here, extract the features. As I mentioned here, we need the features. It's very important. Together with the label, which is the Y. So this is the X and this is the Y. So we have an X and Y here. We pump into the machine learning algorithms. So let the machine learning to learn to achieve a certain accuracy or threshold of accuracy, for example, 80%. Done. Then we can use it for prediction. Okay, we can predict something new. Okay, so where to get a data set? A lot of students ask where can I get a data set? There are a lot of resources that you can get. First one is definitely this Kaggle. But the problem with the Kaggle is this Kaggle here, the data set is not that so-called relevant to our Asian data set. Sometimes you like to predict, like let's say the diseases. But you will look at the Kaggles, most of the data is from European one. You cannot get about the Asian data, so that's the limitations. So otherwise, you can get it from the UCI repository. Okay, you can get it from the Google data sets, or you can get even the NLTK or the Python itself. Some of the libraries already provide you the data set. So otherwise, you can also buy the data set from some other resources, for example, AWS or data.world here. But I'm not encouraging you to buy any data set from a marketplace. Okay, and then the third resources will be the company. So maybe some of you are working your FYP together with some company, then the company will definitely provide you the data set. But again, there are a lot of limitations to use the data set from the company. For example, maybe a lot of the so-called missing data in the in the so-called from the company. So we have a lot of missing data, then you have to so-called perform a lot of pre-processing. You have to do a lot of things, okay, to so-called filter or make your data set is become very suitable or very useful. So this is one of the challenges. And lastly, web scraping, right? So I think this is very common, especially you are doing some recommendation system or you're doing some sentiment analysis. You need the comments from the internet, from the Facebook. Then you have to actually scrap the comment from the Google, from the Instagram, or anywhere from Facebook. Okay. So after you get a data set, if you get a data set from the Kaggle, I believe that most of the data from the Kaggles are already very clean, very perfect. You can actually straight away pump this data set into your pump into this machine learning models. But if you build your own data set, and that's the last technique actually. The last technique will be you find your own data set, which is not practical for your levels, especially to collect a data set. You need a lot of effort. You need to put a lot of time. So if you collect your own data set, you probably have to perform a series of pre-processing. Okay. Some of the data are not really perfect, especially you get it from a company or you collect yourself. Then you have to perform like data cleanings, right? Filter the data first, especially in the text form. So you have to, like last time I show you the NLP, right? You have to tokenize it, you have to lemmatized it, and so on and so forth to make sure the data is clean before you train the models. And some of the models, for example, the decision tree. Okay, the decision tree. So this decision tree will not accept like numerical data. You will have a value for, let's say you have an age. You have this data, 30 years old, 20 years old, 15 years old, and so on and so forth. You cannot straight away pump this data into the decision tree. So this decision tree will throw you the error because decision tree will only accept the data in so-called categorical data. Okay, it's not a numerical value. So we have to perform first. Okay, convert or to categorize. Or let's say this is young. So let's say this is maybe kids. Maybe we have a age 45 above, then we will put it as O. So we have to categorize the data first before we put this data into the decision tree. So I'm going to show you later how decision tree works. So besides that, you definitely have to perform some data integration. If let's say you have a data set from different multiple resources, then how do you combine them together? So it involves a lot of so-called techniques, some knowledge. Imbalanced data. So in the machine learning models, we have to make sure, this is one of the common problems that we may face in the machine learning is we have data which is not balanced. It tends to one side. Let's say now we have a class spam. We have another class is called not spam. So probably you found that the spam email is like about 100. Maybe the not spam email you have quite a lot. So this is actually called unbalanced data. So this is one of the main problem in machine learning, supervised machine learning. If you put this unbalanced data to train your models, the accuracy will probably be very low. So we have to perform again a series of pre-processing. For example, MOT to balance the data first, or you split the data set into different multiple so-called subset and retrain again. So to build a supervised machine learning sounds simple, but the most difficult part will be from the collecting the data and also pre-processing. These two are the two main challenges I feel. Okay, unless you're getting from the Kagers, those data set is already perfect. Otherwise, you definitely have to put a lot of effort to fine tune your data set first. Okay, so these are the machine learning algorithms that you commonly find through the internet. So in the machine learning, we have two type of so-called supervised machine learning. The first one is called categorical or so-called discrete labels, and then the second type will be called known as a continuous values here. Okay, so if you are build a supervised machine learning that deal with continuous value, then these are the simple machine learning models. You have to use linear regressions, ADA boost, gradient boosting. Or if you want to classify something, classify the object into different classes, for example, female or male, the average grade, the excellent grades, then you have to use classifications algorithm. For example, logistic regression, decision tree support vector machine, naive Bayes or K-nearest neighbors. Okay, you cannot perform this so-called decision tree onto the continuous value, or you cannot also use this linear regression to perform the classification. Definitely cannot. Okay, so you have to use the correct algorithms into the correct so-called applications. Okay, so some of the applications in supervised machine learning is like classifications, classify the documents, identify the email spam. So this is the second one I think I already showed you during the practical class. How do we actually identify whether this is the spam email or whether this is not a spam email? Fraud detections, credit card. So this is very common in the companies. Quite a lot of companies they are hiring our students, Thai UMT students, to identify these fraud detections. For the insurance, yes. Credit card, no. I think no. Insurance, yes. We have some company. Disease predictions, stock price prediction, and so on and so forth. Okay. Is that clear so far for what is supervised machine learning? Okay. If good, then let's move on to our first algorithms in supervised machine learning. It's called linear regressions. So I think I have already explained to you very clear what is a linear regression during the practical class. So the linear regression is mainly for continuous value. Okay, so you may see some of the algorithm called linear regression. Then you may see also the algorithm called logistic regression. Okay, linear regressions, and you will see the logistic regressions. Both are different things. So don't get confused. Linear regression is for continuous value. Logistic regressions is for classifications. So this is for continuous value. Okay. and logistic regression is for classifications purpose. So look at the linear regression first. Linear regression is mainly to build a model to predict some continuous values, which you already learned during your secondary school. So let's say now we have what x and y here. So remember, in the supervised machine learning, we need two informations. The first one is called features, and then we have another information called labels. So you look at the pictures here, we have that two information. We have an x here, x as an input of features, and then we have a y here, x as the what, the so-called the labels. Okay, so we try to plot these data on the graph here. Then what we'll do here, we will actually build so-called line that try to join all the data together. It's called a best fit line. So after we build these best fit lines, then we can actually form equations y equal to mx plus c. So once you have this y equal to mx plus c, so this y equal to mx plus c is actually a machine learning model. So this machine learning model is able to predict whenever you have an x here, you just pump in the x into the equations, and you can get the y inside what is the predicted one. So just a recap, probably you already forgot what is linear regressions. You can build the simple machine learning models also using a linear regression from here. Okay, so you have a, let's say you have a data set x and y here. We can actually plot x and y. X is our features, y will be our so-called label, and then we can just right click here. Is it? So can I remember? Things should be add a trend line. Okay, then you can add linear regressions. So it will try to find the best line that can join all these data together, and then eventually you can also display the equation on the chart. So this equation is actually the machine learning models. It's exactly same like what you have learned in your practicals, linear regressions. Okay, so you have a linear regressions, you pump in the x and y, and then you will get this equation, y equal to 11.1. Then you pump in the x, then you can get the predicted y. Okay. Okay, so sometimes you will find out that by using a linear regressions, the accuracy is quite low, right? Because we cannot assume that all the data are linearly correlated. So linear regressions is powerful when the data are linearly are so-called linear correlated x and y here. But what if let's say now you have a data something like this, then maybe linear regression is not that suitable. Then you have to use high polynomial functions. Okay, you cannot use the linear regression, but maybe you have to use high polynomial functions, which is like x power of 2, x power of 3, and above. That's like in this case. Okay, so let's say you have this graph here. So you want to make it perfect, nice. Then you can just right click at the trend line. So you put the polynomial functions, or you can use the log functions, or you can use any other functions. Okay, so make to build a model which is very close to the actual data. Okay, so the higher order that you put, the closer is your predicted model to the actual data. Okay. So in supervised machine learning, there are three common phenomena that you may see after you build the models. The first one is called underfitting. The second case that you will see is called just right. And then the third case is called overfitting. So what is underfit, what is just right, and what is overfit? Underfit is where if you build a model, so let's say this one. So after you build this model, the error is very big. This error is very big. The error is very big. That is underfit. Underfit means that your model is not good yet. Okay, not good yet. Okay, before we talk about these errors here, come back a little bit to the data splitting. If you still remember in the practical, after we have a data set, we prepare a data set. We split the data right into two portions, 80-20. Okay, still remember this 80-20. So after we have these two portions of data here, so this data is actually used for training purpose. So this 20% we use for testing purpose. So after we will use this 80% of the data to train the models. Let's say this is a supervised machine learning models. So we will train it. So we get the answer. Okay, we get these models. Let's say this is y equal to something. So we get the models. Then after that, we have to perform what? We have to evaluate the models. We have to check the models whether it's good to predict something or to predict the unseen data. So what we do here is we will recycle this training data. Okay, recycle. So this one train, we put inside the supervised machine learning, we will get the models. After that, we will recycle the data from the training data set here. We put inside the supervised machine learning, let the supervised machine learning to predict something, to predict the y. Okay, after you predict the y, then we will compare the actual y. So by comparing this predict and actually the actuals, then we will get the training accuracy. Okay, so that is first part. So after that, what we'll do here is we have to use the remaining 20% here. Okay, we pump inside the supervised machine learning. Let the supervised machine learning again to predict a y. To predict a y. So again, we have a predict y. We will compare again this actual y from the tag set. So from here, we will get another parameters called testing accuracy. Then we will have these two parameters. A good models will give you both also about above 70 or 80%. This case is actually can reflect to the student, and let's say you have a book, okay, you're studying a so-called AI. I want to give you a test, so you just study, okay, you memorize exactly everything from the book. Then during the exams, I set the questions solely depend on the books, solely inside the books. Then I let you to answer. So you are able to answer it all correct. Okay, it's called training accuracy because the question is actually set based on the book. What if let's say I set another questions, and this question is not from the book. I try to twist a little bit, I modify the questions, I give a case studies, and then I give your student to answer. If the student is able to answer it correct also, then it means that your testing accuracy is very high also. Testing accuracy is a case where we give something that is never seen by the model to so-called to predict. Okay, so if both of the cases you are able to answer it correctly, then you are actually in this category. So this is what we want, just right. We want a model to achieve both testing accuracy and training accuracy high, above 75%, above 80%. Okay, so what is underfit? Underfitting is where your training accuracy is very low, your testing accuracy also very low. Okay, it means that I set a question from the book, you also cannot answer. It's so-called underfit. The training accuracy is very low. You can't even answer the question that's set from the textbook. We have a last case which is called overfitting. So overfitting is a case where I set the question from the book. You can answer it very good, very well, 80%, 90%. But try to twist the question a little bit, then you cannot answer already. Okay, so it's fall into overfittings where your training accuracy is very high, it's very good, but come to the unseen data set, the testing accuracy is very low. So this overfitting is one of the common phenomenon in supervised machine learning, where you're able to achieve a very good training accuracy, but when it comes to the unseen data set, it is very poor. So this is very common. So how to avoid overfitting? There are many ways lah. So the first thing, you have to make sure that you use the correct models. You have to make sure that your data set is balanced. You have to make sure that your data set that you use is sufficient and a lot. You have to fine tune. So this one, to avoid overfitting, underfit, you have to always make sure the process, each of the process are properly defined. Like whether your data set is enough, whether the features that you extract is appropriate or not. Like for example, the patient. If you put the patient ID into the training process, definitely eventually you will get either one of it. You will get underfit or overfit because you put the wrong features to models train. So you have to put the correct features. Okay. Okay, so that is linear regressions. So mainly we use for the continuous value. For example, you want to identify the sales. Okay, you want to identify the sales. You want to predict the stock price. Okay, then we use linear regression. That's a continuous value. So let's move on to the second so-called classification methods. So we have a 4 types of classification methods: a k-nearest neighbor, a decision tree, support vector machine, and Bayesian classification. So I believe that this one we have also applied. We just apply during the practical class. Like in this case, I just show you the very quick one. So let's say 9 bias. We just call this function from the scikit-learn 9 bias. Import this multinomial NB, and then we just train. Dot fit means train. Train X and Y, then you get the result. Let's say now we want to train using the support vector machine. Call the function scikit-learn linear SVM, train the model. It's just 2 lines of code. Then you are able to build the models in just a few minutes. Pump in the X and Y and call this function dot train. Decision tree. Call this function scikit-learn tree, decision tree classifier, and we have a data set, features, and the Y done. Only 2 or 3 lines of code, then you are able to build the supervised machine learning. It's very simple. But back to the practical, it's not as simple as you think. So let's go through one by one. Are you still with me? Okay, so I just continue. So let's look at the first case here, which is the k-nearest neighbor. So k-nearest neighbor is a distance-based classifier. Okay, it's a very simple yet effective algorithm that makes the predictions based on similarity of data. Okay, based on the similarity of data point in a feature space. Okay, in a space. So the k value here, the k nearest neighbor, the k here is predefined. It's defined by the user. We are the one who set the value of k. Okay, what is the k? K inside the k nearest neighbor is referred to the numbers of nearest neighbors. Means that the data point, the numbers of data points that you will consider when you predict something. Okay, so what is k? K is a parameters that set by you, set by the user, that you want to use how many data for prediction purpose. Okay, I'm going to show you this example. So let's say now you have this data set 2, 4, 6, 8, 10, 11. You have an 11 data point here. So 2, 4, 6. So this data set is referred to, let's say, Brandon. Brandon, are you still with me? Hello? Yeah. Let's say this is the history record. It's a past experience of how many girls that reject Brandon and how many girls they accept Brandon. In the past. In the past. In the past. So the green color refers to the girls that rejected Brandon. So in the past historical data, we have 2, 4, 6, 7. 7 girls. And in total, we have 4 girls that accept Brandon to be his girlfriend for the past 20 years. Okay. And then based on this data here, we try to measure the 2 parameters, which is the length of the hair and also height of the girls. Okay, for each of these girlfriend, we measure the length of the hair, we measure the height of each of the girl, and then we plot it inside the two space. So we have a two space here. We have a two features. One is the length of hair, and then one is the height h, right? And then we know that from here there are 7 girls reject the Brandons and 4 girls accept the Brandon. So remember this case first. We are going to use this case later. How to predict using a k-nearest neighbor. Okay, let's say now we have a new intake, Cinderella X. So join our class. So before Brandon take actions, we can actually use this technique k-nearest neighbor to predict whether Cinderella will accept or will reject Brandon. Okay, so we will go through this. We will see how k-nearest neighbor works later. Okay, so this is the algorithm for k-nearest neighbors to classify a test instance. A small d here is referred to the Cinderella. Okay, k is the parameter that's set by the user. So count the number n of training instance in the neighborhood that belong to class CJ. So this one show you later. But the advantage for the k-nearest neighbor is no training is needed. What does it mean by no training? Do you still remember in the so-called linear regression? The linear regressions, we need to somehow build a model. This is the model. We need to train. Okay, we need to find what is the distance between this data. Then eventually we build this model. So this is so-called training, training time. We need some training time to build this y equal to mx plus c. But in the k-nearest neighbor, no such things. No training process is needed. We will straight away apply whatever data set that we have inside our space to do a prediction. No training time is required in k-nearest neighbor. Okay, so how k-nearest neighbor works is very simple. So come back to the earlier case here. Remember, we have 11 girls, 7 rejected Brandon and 4 accept Brandon before. So we have a new sample. It's called Cinderella. It's a new intake, new girls inside our class. So before the Brandon take actions, we would like to predict first whether Cinderella will actually accept Brandon's or whether we will reject Brandon's. So in this case, before we start to predict, the first thing we have to do is we have to define what is the k value. It is very important. What is the k value? K-nearest neighbor, this is the only parameters that you have to set. What is the k? So let's say k here, we set k equal to 3. Okay, we set k equal to 3. I define k equal to 3. So in our first step, we have to measure the distance between unseen data x with all the data set. Okay, here. So we have an x here. So let's say now we have this data set, 2, 7. Then we have a 4. We have a 4 data set, 4 data, which is accept, and then we have a 7 reject. So first step, measure the distance between unseen data. So this is your unseen data. This is Cinderella. Okay, so we have to find the distance between the unseen data to the data set, which is this distance, D1, D2, D3, D4, D5, D6, and D7, and so on and so forth. D8, D9, D10, D11. So we have to find what is the distance for each of the data set to the new sample, to the unseen data. So this is the first step. So step 2 here is we identify what is the k value, which is defined by the user. In this case, I set k equal to 3. Okay, let's say I set k equal to 3. So this is step 2. So step 3 here is we try to find the probability. I will use the frequency instead of the probability. Okay, so we know that k equal to 3. So what we do here is we try to find which 3 data is the closest to to the unseen data set. Okay, so let's say k equal to 3. It means that we try to find the neighbor data that is closest to the unseen data set. In this case, let's say D1, D2, and let's say D8, 9, 10, D10 are the 3 data sets closer to the X, let's say these 3 data. Okay, but first thing first, you have to measure the distance. So from the distance, then we will know that which data is actually closest to the unseen data. Okay? Okay. So after that, then we can come up with the probability or the occurrence. So in this case, we will know that within these 3 samples here, two samples that belong to reject. Okay? Within these 3 samples, there's only 1 sample that is accept. Then eventually we can come up with a conclusion that within these 3 nearest neighbors, Cinderella most probably will belong to this class, which is reject plantain. So this is how we do our predictions. We calculate the distance, okay? We calculate the distance, okay? And then we find how many data is actually included inside these k values. Then within these k values here, which classes is having the highest frequency. Then we can predict this new sample is belong to that class. Okay. Is that clear? Okay. Okay. So how about this? Can you help me to predict if, let's say, we have a 6 NN, which is a 6 data point that you use to do the prediction. So we have a rectangle box here. So this rectangle is something unseen data. So we use k equal to 6. 1, 2, 3, 4, 5, 6. Can you help to predict whether eventually these new samples belong to which group? Is it computer science, engineering, or art? Computer science, that's very good. Because within these 6 data points, okay, the computer science has 5 data points. At 5 compared to engineering, there's only 1, and 0 is in art. Then we can say that this square here, this unseen data, will belong to computer science groups. Okay, but first thing first, you have to measure the distance. So this one, I assume that I already measured the distance, and these are the 6 closest points to this unseen data point. Okay, so you can see that in this k nearest neighbors, there's no training time is required. We are no long. We don't need to spend the time to build a models like this. No models is required. We straight away put the unseen data point, and we measure the distance, and we find the frequency. That's it. So k nearest neighbor is a distance-based classifier. Okay. So k nearest neighbor is can deal with the complex and arbitrary decision boundaries. So yeah, it's very slow at classification time. Yes. So the third one, slow in classification time because we need to measure the distance. You assume that you have a lot of data, then you have to measure the distance for each of the point. So it's time consuming in classification, but in terms of training time, no, 0. No training time, but it consumes large amount of time during classification. Okay? So k nearest neighbor does not produce any understandable models, just like linear regression. Linear regression, we are going to produce some models here. But k nearest neighbor, no models. We straight away find the distance, group the data, find which data is having the highest frequency. Okay? So this is k nearest neighbor. Let's move on to the second one. Decision tree. Decision tree is among the most difficult models in supervised machine learning. So what is decision tree? Decision tree is a model that eventually build a tree for you and to make a decision. That's why it's so-called decision tree. Okay, it's a tree. It's a tree. Eventually, after you build this decision, you call this function. So it's going to build you a tree that helps you to make a decision. So this is so-called the root node. Okay, so this is so-called a leaf node. So in between, there will be a lot of features, a lot of characteristics. Okay, so decision tree is a tree that will assist you to make a decision eventually. So decision tree is a flowchart like three structures. Internal node denotes a test on attributes. So the branch represent the outcome of a test. So leaf nodes represent the class labels of classifications distributions. Okay, so let's say now you have this data set. So let's try to understand the data set first. So this data set consists of 5 attributes: age, income, student, credit rating, and by computers. So this data set is basically to find out, to identify the behavior of humans. If let's say we have this is the actual data set. Let's say now we have a person, right, walk into the computer shop. So this person less than 30 years old is having the higher income and is not a student, is having the fair credit ratings. And eventually he just shop, okay, walk, and then eventually he's not going to buy any PC. Then we shut down. Okay, so less than 30 years old, high income, not a student, fair credit rating, not going to buy a PC. So we have a second customer walk inside the so-called the shop. Less than 30 years old, high income, not a student, excellent credit rating, is not going to buy the PC again. So we jot down the data set. So we have a third customer coming. So this customer between 31 and 40 years old, high income, is not a student, fair credit rating. Yes, eventually he buy the computer. Then we shut down. So we have a lot. We have how many records here? 2, 4, 6, 8, 10, 12, 14. We have 14 records. So this is the data set, the actual data set that's already happened. Then we collect this data set. So let's see how to build the decision tree machine learning models using this data set. You will call the functions in the so-called the scikit-learn. So eventually, this is the tree that will build for you. Okay. So I'm going to explain to you what is the principle behind the decision tree. But let's understand first how this decision tree works. You have this data set. You will call this functions decision tree. So this is what we get. So how to interpret this decision tree is very simple. For example, let's say now you have unseen data, age less than 30 years old, a student, yes, excellent in credit ratings. So we would like to predict whether this customer will buy the computer or not. So we can just go to this decision tree and check. In the first attribute, what is the age? So in our unseen sample here, less than 30 years old, then we go to this direction, less than 30 years old. Okay, so the next question is whether this customer is a student or not. Then we have to check. Yes, if he is a student. If it is a student, yes, eventually he will buy the computer. Okay, so this is how we interpret the decision tree. It's a tree that will make a decision for you. Okay, are you still okay? I'm like talking to myself. Okay, so this is the tree that will make a decision for you based on some unseen sample. For example, in this case, let's say now you have an age more than 40 years old. The credit rating is excellent. Then we can just go to this branch for more than 40 years old. The credit rating is excellent. Then this customer will not buy the computer. So my question is, why the first layer here is age, but not students, but not credit ratings? How the decision tree knows that in the first level we should put age first, okay, but not the credit rating. So after the second layer, why do we need to put the student credit rating, but not the so-called the income? So decision tree will build this tree based on a parameters called information gain. Okay, so this is very important. Information gain. So the decision tree functions will identify which attributes or which features is the most appropriate to put as the root node based on this information. Okay. if you put different attributes at the first level, if you put student, then it will give you the totally different decisions. If you put criteria rating, then it will give a different decision to you also. So it is very important to identify which so-called attributes to put at the highest level, which attribute is suitable to put at the second level, third and fourth. So how to identify the so-called attribute at different levels? It depends on this information gain. Okay, so this information gain here, it depends on two parameters. The first one, informations. The second parameter is called entropy. Okay, the information gain here, it depends on two parameters. The first one is called informations. The second one is called entropy. So this is the equation for information gain. So we have a 4 attribute just now, if you still remember. So we have age, we have an income, we have a student, we have criteria rating. So we have these 4 attributes. So we need to find out what is the information gain for each of these attributes. Then after that, which one is the highest information gain? Then we will put as the root node. Okay, so let's say age. Age, after we calculate, we will get the highest information gain. Then we will put the age as the root node. Then after that, there are another income, student, and criteria ratings. So we have to identify which attributes to put at the second level. Again, we have to recalculate again the information gain. See which one is the highest. If let's say in this case, income is highest, then we put here income, and so on and so forth. Okay. Maybe after income, we calculate again which between these two, which one is the highest information gain. Let's say student, then we put student. And then lastly, maybe criteria ratings. So this is how we build the decision tree. Okay, so based on two informations and the entropy. So the information here is referred to how much information it will provide to you if we put the particular attribute at this level. So we want the attributes is able to provide as much information as possible. Okay, that's why we have this information. What is entropy here? Entropy is referred to how randomness of a data set. If your data set, let's say student, okay, student give you a very random data. You can't even differentiate based on this student whether it will buy a PC or not to buy a PC. It means that this data is very random. Okay, it's very random. You can't even differentiate whether students not if he is a student or not. Okay, let's say now you have a student. Let's say now you have a quite number of students will not buy a PC, and you have quite a number of students that will buy a PC. So this is very high randomness. It's very random. You can't even differentiate whether if you have not a student will buy a PC, or yes, if a student will buy a PC. You don't know. We want to attribute is something like let's say income. Okay, if the income is very high, yes, then he will buy a PC. Then if low, maybe 1 or 2. Okay, not to buy a PC. So this is very obvious. So this is what we want. Okay, so this data set, it means that it has a very so-called low randomness. So we have an information minus entropy. So if the highest values 1, then we will put at the root nodes. Okay, so let's see how to build the decision tree using the information gain. So remember, we have 2 parameters here. The first one is the informations. The second information is the entropy. So let's say now we got nothing. Okay, let's say now we got nothing. So this is the tree. So we don't know which attribute, whether age, income, student, and criteria rating, we put in as a root node. So how to start? First, you have to find the information for the data set first. Okay, so how to find? So first, you have to identify inside your data set how many customer will buy the PC, how many customer will not buy the PC. So from here, how many yes, how many no? We have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 4, 6, 8, 9. 9 yes, 2, 4, 5, 5 no. So we just substitute 9 yes, 5 no here. We put this 9 and 5 into this equation. So this is the equation, no need to worry, you just pump in the value inside the equations. So you have a 9 divided by 14 log 2 of p divided by 14 minus and so on and so forth. You will get overall information for 0.94. So the overall information you will get 0.94 here. Then what you will do here is you have to use these informations to minus the entropy. The entropy for each of these attributes, for example, the age, the income, the students, and the credit rating. So how to find the entropy here? You have to use the second so-called equations shown here. Okay, so this is the equation to calculate the entropy. Okay, so let's start with the first attribute, which is the age. Okay, so this one we will calculate later. The student, the credit ratings, and also the age we will calculate later. So let's start with the first one, which is the age first. So under the age data set here, we try to categorize. There are how many categories inside the age attributes? There are 3 categories. Less than 30 years old, between 31 and 40s, and also the last one is 40. So we have 3 categories. Then you can draw a table, put 3 categories: less than 30 years old, between 30 and 40, and more than 40. So inside this table, we have to find out within this category less than 30 years old, how many customers will buy the PC and will not buy the PC. Then go back to here. Okay, less than 30 years old, how many will buy? 1, 2, 3. 3 not going to buy. Okay, and then 1, 2, 2 going to buy. So you will have this table. 2 going to buy a PC, and 3 is not going to buy the PC. Then we repeat for the second category, 30 to 40 years old. 30 to 40 years old, yes, this one we have only 1, 2, 3, 4, 4 data. Okay, within these categories, how many will buy? 1, 2, 3, 4. 4 will buy and 0 not to buy. Okay, so we will get 4, 0 here. Repeat for the last category, 3 and 2. So what we'll do here is we will pump this data. We have a P and N. We will pump this data again, use the first equations to get the information first. Okay, to get the information. So by using the information, we put this data into this entropy. So this is the entropy. So we have a P plus N. This is P plus N, 2 plus 3. So we have a 5 here. Divided by total P plus N. Total P plus N will be the total 2 plus 3 plus 4 plus 3 plus 2, you will get 40. And multiply the information, which is 0.971. So this is for the first category. Okay, then you add up the second categories, which is this one, 4 divided by 14, multiply 0, and plus 3 divided by 14, multiplied by 0.971. So eventually you will get this value, which is 0.69. This 0.69 here is the entropy for the age. So we have this 0.94, you have to minus the entropy, you will get the information gain, which is 0.25. Okay, so once you get the this information gain, you have to repeat for the income, students, and credit rating. Repeat the remaining features. So this is the information gains that you obtain. Then you compare which one is the highest. So obviously age is the highest lah. So if age is highest, then we will put the age as the root node. So this is how the decision tree works. So it depends on 2 informations and the entropy. So after that, under the age, we have 3 branches, right? So we have a less than 30 years old. So we have a 30 to 40 years old. And lastly, more than 40 years old. So again, we have to identify which attribute, whether income, student, or credit rating, to put in the second level. Again, we have to repeat the same process, find the informations, okay, which is the information minus the entropy. Repeat the same process, identify among these 3 which one is having the highest so-called information gain, then we put the attribute inside the second level. Then repeat again. Repeat. Same goes to the second branch and the third branch. So it involves a very huge calculations in decision tree, but fortunately in the Python notebook you just call a functions. You just call functions, then it will build a tree for you. But this is the theory behind the decision tree. Okay? Okay, so after you build a decision tree, so each of this branch here you can build a rules. For example, in this tree, so we can actually build a so-called the rules. For example, in this case, if age less than 30 years old and student no, then buy the computer. So each branch here we can actually interpret or think that this is actually one rules, and then this is second rules. We have a third rules, fourth and fifth. So we have actually total 5 rules here. So these rules will help us to make a decision if let's say we have something, we have some unseen data. Okay. So as usual, so each of these algorithms may face overfittings. So especially in the decision tree where you have a lot of attributes, then it will build a lot of branch for you. Okay. If you have too many branch here, then overfitting may happen sometimes. So to solve the overfitting in the decision tree, so there are 2 techniques that you can do here. Is the first one is called pre-pruning. Okay, pre-pruning is a process where we define a level before we ask the decision tree to build a tree for us. For example, in this case, we set a threshold value is equal to 3. Then it will just build a decision tree up to a 3 level. Okay, level 0, level 1, level 2, level 3. Then that's it. So this is so-called pre-pruning. We predefine the so-called the parameters. Post-pruning. Post-pruning is when we build the tree first. Okay, we build all the tree. Done. Okay, maybe we have a lot of branches here. Okay, branch. Okay. And we have to manually check whether if I put away these nodes, whether the result will be the same or not. If the same, then means that this node is redundant, then we can remove. Then we check. Let's say now we have this node. So we check. If let's say we get the result from this situation, and we check also the accuracy after we remove this node, whether the accuracy is the same. If the same, that means that this node is actually redundant, then we can actually remove it. Repeat the same, repeat until you get a good tree. But this post-pruning is a very complicated process. You have to do it manually. You have to check one by one. But pre-pruning is another problem is there's no standard way to set what is the optimal threshold here. Okay? Okay, so we have another tool. A lot. Okay, so support vector machine, I'm not going to touch the algorithms or the calculation for the support vector machines. This technique is especially to find the best hyperplane to segregate the data into 2 or more classes. Let's say you have a data set like this. Okay, if we use a support vector machine will try to provide the best hyperplane. Okay, the best hyperplane to segregate or to separate the 2 classes. We can have this line, this line, this line, but the support vector machine will find the best one for you. In this case, so this is the best one. Okay, so this is the best one. So we find out, okay, so this line is the best to segregate these 2 classes using called marginal, cannot remember the term, the margin, okay, the margin. Try to maximize the margin. The distance between this line and also the point here. And this point here we call support vectors. Okay, so you have a lot of equations, but you don't need to understand the equations. But the ideas of the support vector machine is to find the best hyperplane. If you have a 1D data, okay, let's say this. So we will have this hyperplane. in only 2D. You have a 2D space here, then we will have a line here. If you have a 3D so-called data, then we will have a plan. We have a plan to segregate the points, the data. Okay, so sometimes we could have a data which is not obviously distinct like this. So not all the case we will get this kind of data, very obvious one. But sometimes we may get this kind of data. Okay, where two classes are mixed together. So how to build a hyperplane? So normally in this case we have to transform this data from 2D into a 3D space first. Okay, and then from a 3D space there will be a very obvious differences, right? Then we can build a hyperplane to segregate these two different data sets. Something look like this lah. You look at this animations. Okay, so let's say now you have this data set, this very scattered one. Okay, then we will have to transform all this data in 2D plane into a 3D space first. From there, then only we can generate the support vector machine will will find the best plane for you to segregate these two different data sets. Okay, and then we will transform back to the 2D plane. So this circle will be your support vector machine. Okay, not necessarily a straight line. Sometimes it could be a circle. So you can actually build your own simple support vector machine through a Excel file here. Let's say now you have a scatter point, right? So you can actually transform this 2D plane by modify the equations. So you can actually generate or transform these two data set into a 3D space. Okay, you have a very obvious data here by applying some equations. So from these equations, we can convert it back to the 2D. So then it will be very obvious. Okay, that will be very obvious. So you have a one group outside the circles, and there's one group of data set is within the circles. Okay, so but just for your information, there will be no such SPM question in your midterm or final. Okay, so let's move on to the finals. Last algorithms here is a naive Bayes classification. It's one of the very famous techniques in the supervised machine learning using a probability techniques. So for this naive Bayes, you just need to understand or to remember these equations, which is so-called P H D equal to PDH multiplied PH divided by PD. So these three parameters, you can get it from a data set. Okay, you can get it from data set. There's a terms lah, but it's not really important. This is called posteriori probability. This is so-called likelihood. This one is so-called prior probability. This is so-called marginal probability, marginalizations. It's not very important the terms, but you must know how to apply this equation to predict the unseen data. Is it whether belong to class A or is it belong to class B? So this H here is referred to hypothesis. Okay, or the class. So this D here is referred to the unseen samples. Okay, and then this is the conditional probability you can get from the data set. So this is the prior probability you can get from the data set, and this PD also a data that you can obtain from the data set, and this one is actually a constant. Okay, so this PD here is actually a constant. So let's move on to the example that how do we predict using this Bayesian theory. So this is all theory lah, huh? Okay, let's say now you have this data set. So there are 5 attributes: outlook, temperature, humidity, windy, and class. So it shows that whether a person will play a tennis under several conditions. If let's say Brandon again, okay. So we want to know whether Brandon will play a tennis. So it's very so-called it depends. It depends on the environment, okay, and then decide whether he want to play tennis. So if let's say it is a sunny day, hot temperature, the humidity is high, it's a windy day. It's not a windy day, then the Brandon will not play tennis. Okay, if let's say it's a sunny day, it's a hot temperatures, high humidity, it's a windy day, then Brandon also not to play tennis. So when Brandon will play tennis under this condition, okay, overcast, hot, high force, and so on and so forth. So these are the data set that when Brandon will play the tennis. So these are the actual data set that we record. So what if let's say we have a new samples, which is like this one, okay. Let's say now we have these samples, rain, hot, high, and force. So we want to predict whether Brandon will play tennis or not to play tennis if we have these new conditions. But these new conditions you will never get from your data set. Can you find any data set where it's a raining day, temperature is hot, high humidity, and not windy? You can't find it. So we want to predict if let's say we have something new data set, whether Brandon will play tennis or will not play tennis. Okay, so how to predict using this Bayesian theorem? Okay, follow these equations. So there are two values that we have to generate. The first one is based on these new samples, which is rain, hot, high, force. Whether Brandon, yes, will play tennis or not. We need to find out this one. And also we have to find out this one also. Based on these conditions, Brandon will not play tennis. So we have to find out these two probability. Then we compare which one is the highest. Then we can make a conclusions on whether this Brandon will play or not to play tennis. Okay, so how to find this value? Based on this PDH multiply PH. So how to get this likelihood here? Okay, then we have to go back to the data set. Okay, so what is PDH here? It means that from the data set, okay, what is the frequency? If let's say the data is rain and it belongs to yes class. So come back to this table. How many outlook is rain and the class is actually yes. So we have to find 1, 2, 3, right? Okay, so it is 3 over 9. 9 is then for the total case where the Brandon will play tennis. So how many yes here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. That's why you have a 3 over 9 here. Then we go to the next attributes. Hot. In your data set, how many hot temperature Brandon will play tennis? 1, 2. Only 2. Okay, so they will have 2 over 9. Repeat for the third attribute, high. How many case where if the humidity is high, Brandon will play tennis? 1, 2, 3. 3 also. 3 over 9. And lastly, force. Okay, how many case force but Brandon will play tennis? 1, 2, 3, 4, 5, 6, 6 over 9. So done. So this 4 value here is referred to the likelihood. Okay, it's referred to the likelihood. Multiply. What is pH? pH is what is the probability that Brandon will play tennis. So out of all the cases here, how many yes? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, multiply 9 over total data set we have 2, 4, 6, 8, 10, 12, 14. 14. So this one is actually pH. Okay, so divided by PD. So whether you want to divide by PD is up to you because PD is a constant. If you have a two value, divide by the same value, you will get back the same ratio. So whether you want to find PD or not is up to you. If you don't want to find, it's okay. You will get the same answer. Not the same answer, same ratio. Okay, you want to find, so how to get the PD here? PD is, okay, where to get the PD here is, okay, PD is based on the particular features. Okay, how many belong to ring? Okay, then we have to find out how many belong to ring. 1, 2, 3, 4, 5. Okay, you have a 5 over 15. Okay, in the hot temperature, how many inside these attributes, how many hot case here? 1, 2, 3, 4. 4 over 14. Okay, and the third attribute, high. How many high here? 1, 2, 3, 4, 5, 6, 7. And lastly, how many false? 1, 2, 3, 4, 5, 6, 7, 8. 8 over 14. Then you calculate this, multiply this, divide by this value, you will get. Can you help me to calculate? You will get something like 0.010582 divided by 0.029. Repeat for the second case. Okay, repeat for the second case, you will get 0.018 divided by 0.029. Okay. Calculator. But you don't need to use calculator also no lah. This is a constant value, so this is higher. Then we can make a conclusion that if you have this new unseen data, Brandon will definitely, probably Brandon will not play tennis because the probability is much higher compared to yes. Okay, so this question is very important. You must know how to calculate the probability for each of the classes based on the data set given using these equations. You just need to remember this equation, then you can solve the questions. Okay, so let's move on to the last sections. So after we so-called build the models using the support vector machine, Bayesian theorem, linear regressions, then we have to assess the models, whether it is good or not. So it depends. If you're using a regressions, then we have to use like mean square errors, right? I already covered during the practical class. You just call a function MSE, mean square errors, or you can use R square. These are common techniques to measure the differences between the actual data and also the predicted data. If you're using the classifications, then these are the common techniques that we use to measure a performance of a model: convolution matrix, cross validations, ROC curve, or the PR curve. So one of the famous one will be the convolution matrix. So it's a matrix that to describe the performance of classification model based on the actual data and also the predicted value. So this is the common matrix form that you will see here. Okay, so if let's say you are doing the binary classification, you will get this four value here. So what does it mean? So let's say you want to build a model that to predict something whether it's yes or not. So if your model is able to predict yes, and in actual it is also a yes, so you will get a value 100 here. So this 100 means that if you predict 100 cases, in actual there are 100 yes, they belong to 100 yes, but your model is able to detect that these cases are belong to yes, so this is 100. Okay, if let's say your models predict that this is a 10 yes here, but in actual they are not belong to yes case, they are belong to no, then you will have this value here. But that is not important. The most important here is how we define this term: true, negative, false, positive here. In so-called the scikit-learn, you just call a function, if not mistaken, you call a convolution matrix, then it will build the table for you. But how to build this table actually is not that difficult. Let's say in this case we have a 100 case, where actual also yes, predict also yes, then we will give a name called true positive. Okay, means that what you predict is actually the actual case. Then we call true positive. So we have a case where you're not going to predict some okay. This one is called confusion matrix. It's a matrix that will confuse you. It's very difficult to explain using this case. So in this case, let's say we would like to predict. We already built the models. We want to predict whether these patients are infected with cancer or not. Okay, cancer. Okay, yes. So we want to predict whether a patient infected with the cancer or not. So this is our objective. Okay, so this is our objective here. Okay, so we can build a table. Okay, so this is your machine learning prediction. So this is the actual data set. Okay, so in predictions, there will be two output, whether you are able to predict it's a cancer or you are not able to predict it's a cancer. So we have a predict yes. So we have a predict no. Okay, so in the actual data, we also have two labels, whether it's a yes cancer and also a no cancer. So means that the patient is infected with the cancer or the patient does not infected with the does not infected with the cancer. So we have this data. Okay, if let's say what you predict is the actual data, then we will put this column. So in this case, it's 100. Okay, if what you predict from the machine learning in actual is not infected with the cancer, then we put inside this column. Let's say this is 10. Let's say your machine learning predict that this patient's got no cancer, in actual also no, so we get this, put this column. And lastly, we have a predicted no, but in actual yes, this patient has a cancer, so we put here. So how to assign this term called true positive, false positive here? You have to identify first what is the meaning by this true, false, negative, and positive. Okay, that is the meaning for each of these terms. So the positive here is actually referred to the objective. This negative positive is referred to the objective. If your objective, just now I mentioned, your objective is to detect whether this patient got the cancer or not. So this will be our objective. Yes. Right? Our objective is to predict whether this patient infected with the disease or the cancer or not. So this will be the label. Assume that this is just a label. Okay? So another label that we have is not to get a cancer, right? So we put as a negative. This is not our objective. Our objective is to detect whether this patient infected with the cancer or not. Then we give a label called positive. Other than that, then we assign a negative. So what is true and false here? It means that whether you are able to classify correctly. If you are able to classify correctly, then it's called true. If your machine learning model is not able to predict correctly, then we assign the term called false. Okay, so after you understand this meaning here, then we come back to this table. Is what you predict yes? You predict correctly, right? Actual data also yes. Predict also yes. So predict correctly, so we give a true. So this yes here is our objective, right? It's our objective here. So this is a true positive. Okay, so how about this one? We predict yes, but in actual it's a no. So wrong prediction. If wrong prediction, we give a false here. False one. Yes is our objective. So we already predefined the label. Yes is actually a positive. So we have a false positive here. So what you predict actually is also not, means that you predict correctly. True. So but however, no is not our objective. So we give a negative here. Okay, negative. We already predefined the class name. And lastly, we predict no, but actual is yes. So this is something wrong. So this is not our objective, so we will have this false negative. So this is how we provide the labels. So why do we need to generate this true negative, false positive here? Is later on we want to put this value into these equations to identify what is the accuracy, prediction, and also the precision and also the recall. So by identifying the accuracy is not sufficient. Normally we have to find out also what is the value for the precision and also the recall. If the values we are able to achieve like 80% above, then we can say that your model is good enough. Okay, so make sure that your value should be more than 75 or 80% for each of these parameters. It's not only for accuracy, but precision and also recall. You have to make sure that 3 of them are achieved a very high value here. Okay, so this one is just an example. So we have a second technique to measure the performance. It's so-called ROC and area under the curve. So this ROC and area under the curve is mainly used for binary classification. Okay, it's mainly used for binary classification. What is binary classification? Means that you have only 2 classes. Okay, you have A, you have B. Only binary classification. Then we can use this technique called ROC, area under the curve. So in the Python, you can just call a function from the sklearn, ROC underscore curve. Then it will give you a value. Okay, it will give you a value. If this value is above, this value will be between 0 to 1. Okay, the area under curve. If the value is like between 0 to 0.5, then this is very poor classifier. It's very poor performance. If you have a 0.5 to about 0.75, something like that, is considered average, just accepted models. If your model is able to achieve more than 0.75 or above, then we will see that this is a very good binary classifier. Okay, so remember this technique is only used for binary classifier, and the value is between 0 to 1. Okay, but it's not common that we use ROC curve. Normally we just use confusion matrix. Okay, then the last technique is called cross validations. When to use cross validation is under several conditions. Remember just now that I mentioned about imbalanced data. Sometimes we could have a data that maybe 1,000 belong to no, maybe only 200 belong to yes. So if you have these cases, then maybe you can use a cross validations to validate your result. So what does it mean by a cross validations? It's where we have let's say we have a 1,000 data set. We can actually split into several subsets. Let's say 10-fold. 10-fold means that we split this 1,000 into 10 different subsets. Each subset will consist of 100 data sets. Okay, 100, 100, 100. We have a 10-fold. And then what we do here is we will use the randomly, we will choose the 9 data set, okay, as the training samples. The remaining ones as the test samples. First iteration. Go to the second iterations. Maybe we will choose this one sample as the test sample. Remaining 9 samples here as training samples. Third iteration. We choose all this as a training samples and this as a testing sample. Repeat for 10 times. So each training process, you will get accuracy, precision, and recall. So you iterate for 10 times, you will get 10 accuracy, precision, and recall. That is the average. Okay, so that is called cross validation. We split the data set into so-called 10 different subsets, and then we train the models. Okay. So yes, finally that's it. Okay, so yeah. So actually, this machine learning is one course 14 weeks one. So I have to compress everything only 1 week. So if you cannot understand, you cannot digest. I can understand. So but go back and study lah. I think machine learning is definitely the future. I believe that your assignment also you're going to use the machine learning to build even the chatbot, recommender system. Most of the application now are using machine learning. So it's good also for you to understand, not just to apply like in the Pythons, you just call functions, apply, but if possible, try to understand the ideas, like the concept behind, so that you can customize your own models. You can identify what is happening if let's say the accuracy is very low. Not just call the functions, but you know what is the parameters, you adjust the parameters. Okay, so any questions so far for the machine learning models? It's the most difficult chapters among all. A lot of theory.